Hi guys, I hope you're all doing well. This is going to be the first day on bearing. We will spend 2 days on it, so this will be the first video. I'm going to start by introducing the idea of bearing, and then we'll go through 3 word problem examples. Okay, so bearing, it's a direction from a fixed point that's used in navigation. So you'll see a lot of examples with boats and airplanes and stuff like that. Right, now traditional bearing is from due north. Okay, traditional bearings always from due north and measured clockwise, and it's going to be an angle between 0 and 360 degrees. So these first 4 that we're going to talk through are traditional. Okay, you're just given an angle. Okay, so if it's always from due north, here's my due north. Okay, and 41 degrees from due north. Well, this would be 90 degrees if we go clockwise. Okay, this would be 90. So 41, we'll just estimate it's kind of like that. Okay, 122 degrees. So remember, it's always from due north. Okay, so we had said that this would be 90, so this would be 180, so 122 would be like there. And try and give a rough estimate of where it would be. Okay, so 244 degrees. Here's my due north. So if this was 180, we need to go 64 beyond that. So this would be 270. So like here-ish. Okay. 348 degrees. Here's my due north. So all the way around once would be 360. So we're just going to be shy of that basically. So it's going to look like that. Okay, so those are traditional. You're just seeing one number for the angle. Okay, and that's it. Okay. Directional bearing is different. Directional bearing is always going to be between 0 and 90 degrees. That is important. Notice here you have a north and an east or a south or a west or some type of direction given to your bearing. Okay, so what this is basically saying, and I kind of read it a little bit backwards than how it's written, this is saying that we are going to be 22 degrees east from north. So if this is my north, we want to go 22 degrees east of that. So east would be to the right. Okay, so 22 degrees, just rough estimate, would look like this. Okay, so this one is saying 47 degrees west from due south. So here's my due south. So west would be to the left, so 47 degrees west of south. Okay, this one. This is saying basically 50 degrees west from north. So here's my north. So west would be this way, so 56 degrees west of that. Okay, this one is saying 88 degrees east from south. So east would be to the right, so it would look like that. Okay, there are 4 here that you can try. If you want to pause it and take a look at those, try those. When you hit the play button, I will draw those in. Okay, hopefully you're okay with those. So those are your directional bearing. Okay, they're always between 0 and 90. Okay, so let's start to talk through a couple examples here. The hardest part for these are going to be drawing the picture. Okay, so if you need to pause, back up, replay these so you can get an idea of how these work. Okay, so 2 towers are 20 miles apart. Tower A is due north from Tower B. A fire is spotted from the towers and it's bearing from Tower A and Tower B are these 2 values respectively. How far is the fire from Tower B? So a couple things. First of all, you want to draw a vertical dotted line from each point. And I'll show you when I draw my picture what I mean. This part is super important here. You want to label everything. Okay. And the third thing, which is going to be super important, you always want to find your 90-degree angle. Okay. For this section's labeled right triangle. So there has to be a 90-degree angle in what we're doing here. Okay, so first of all, let's start this picture. So Tower A is due north from Tower B. So here's A, here's B, and they are 20 miles apart. Now, in this one, I don't really need to draw a dashed vertical since this is already vertical. Okay, you'll see it more so in the next example, but if I were to draw it, it would look, okay? A fire is spotted from the towers. It's bearing from Tower A. So I'm going to focus on Tower A here. Okay, so it's bearing from Tower A is 56 degrees east of south. So if I'm looking south at Tower A, 56 degrees east is going to be over here. So like this. Okay. Now from Tower B though, okay, and I might have to extend this in a second to get these lines to meet up properly. Okay, from looking north, it's 34 degrees east from there. So 34 degrees east, something like this. All right, so I am going to have to extend these to get them to meet up here. Okay, so do you see how from looking south, so this would be looking south, 56 degrees to the east from that line. This one looking north, we're 34 degrees east from there. So if you add 56 and 34, you're going to get 90, so then clearly that's your 90-degree angle. Okay, so notice how I'm labeling everything so far. And we want to know how far is the fire, so this is my fire, from Tower B. So we're looking for this piece. From here, it's just a simple trig ratio. The hardest part is going to be labeling your picture. So if you look at this, you could use the 56 degree angle or the 34. It's really up to you. Now, depending which angle you pick to use, okay, will depend which trig function you're going to use. So I'm going to do 56. That's just what I chose to do. So sine of 56 equals opposite over hypotenuse. Since this side's opposite and that's hypotenuse, that's why I use sine. Okay, so sine of 56 equals x over 20. And we could solve that and we would get 16.6 miles. So the math right here is really not that hard. It's just getting the picture set up. Okay, let's look at another example. This one takes a little bit to kind of piece together, just warning you. So the bearing of a lighthouse. Okay, so I'm going to place my lighthouse right here. From a ship 9.2 kilometers away is 30 degrees 30 minutes. Well, let's back up. Maybe I shouldn't put that there first. Let's do the ship first. My bad. Okay, so here's my ship. So the bearing of a lighthouse from the ship. So from this ship. So I'm going to draw this vertical through my ship. Okay, so the bearing to that of the lighthouse is 30 degrees 30 minutes. Now notice there was no southwest, northeast, none of that. So that means it's a traditional bearing, and you're always going to go from due north for the traditional bearing. So 30, that's basically 32.5 degrees, because 30 is half of 60 minutes. So 32.5, let's just estimate, so like this. Okay. And it's 9.2 kilometers away. So let's put my lighthouse right here. Okay. Now, how far must the ship sail due north? So the ship's going to start to move this way for the bearing of the lighthouse to be 122.5 degrees. So we want this ship to go somewhere up here. And once again, this is traditional bearing. Okay, so from this vertical, I go 122 degrees. So this would be 90. So let's go like 30 some beyond there. So like this. So this would be the 122.5 degree angle because traditional bearing always goes from due north. So think about it. This is a completely straight vertical line. So these two angles right here should be supplements. So if you take 180 and subtract this, you're going to get 57.5 degrees for this guy. Okay? So we have our vertical line. So far we labeled everything. Okay? We need to find that 90-degree angle. So if this is 57.5 and 32.5, you add those up. What's left is 90 degrees. That's your 90-degree angle. We want to know how far the ship has to sail from here to here to get that bearing of 122.5. So we're looking for this piece right here. Okay, so I chose to use the 57.5 degree angle. You could use 32.5. It doesn't matter. It would just change which trig function you use. So from here, I have my opposite and my hypotenuse again. So I did sine of 57.5 degrees equals 9.2 over x. Okay, so if I would cross multiply, oops, I'm essentially taking 9.2 divided by that sine of 57.5 degrees, and I would get 10.9 kilometers. Okay, let's look at one more. So a surveyor wishes to find the distance across a swamp. The bearing from side of the swamp from point A to B on the other side is 32 degrees west of north. The surveyor walks 50 yards from point A to another point C. Okay, let's start to back up here. So here's my swamp is in here. Okay, so I have point A, point B. Now the reason I chose to set them up that way, okay, the bearing from point A to point B. So if I draw a vertical through this guy, I'm going to draw a vertical through this guy as well. I want to go 32 degrees west from north. So 32 degrees west from north would look like this. Okay, so that's why I position them the way they are. Okay, now the surveyor walks 50 yards from point A to another point C. So I'm going to just put my point C here, make this 50 yards, such that AB is perpendicular. So AB is perpendicular to AC. So that this is a right angle. Okay, so let's just real quick, if this is 32 degrees and this total is 90, if you subtract it out, this side's 58 degrees. Keep that in mind. Okay. From point C, the bearing to point B, okay, is going to be 68, so let's draw a vertical through this, 68 degrees west of north. So here's my north, so 68 degrees west. So we're saying, sorry, that's not super great to scale, but that angle would be 68 degrees. Okay, find the distance across the swamp from A to B. So we're really looking for this guy. Okay, so once again, the math's not going to be hard. We just got to break down how we drew it. So let me go back one more time. The bearing from point A to point B, okay, is 32 degrees west of north. So that's why I put A down here, because I knew 32 degrees west of north was going to go that way, so I knew point B was going to be that way. Okay, then he walks 50 yards to create this point C such that AB is perpendicular to AC. Then the bearing from point C, okay, and since it's directional bearing, okay, drawing your vertical, we want to go 68 degrees west of north. Like I said, it should probably be a little bit smaller there. That's my bad. Okay, we can find that guy. So here's the right angle. Okay, and they told us that. So now think about this. Okay, if this is 58, you need one of the other angles to solve this problem. So if this is 58 degrees, these vertical dashed lines are technically parallel. Here you have a transversal. So alternate interior angles would make this guy also 58 degrees because we need an angle inside this triangle to solve this. Okay, right? You can't use the 90-degree angle to solve it. You need one of the other two angles. So if this is a straight line, this angle, the 68, this guy, and this 58 should add up to 180. So if we subtract those out, we can find that this angle is 54 degrees. So now we have a non-right angle inside the triangle. So according to this angle, this is opposite, the 50 is adjacent. So tan of 54 equals opposite over adjacent. You can cross multiply that and solve and get 68.8 yards. So like I said, you might want to back up and replay this last one. Okay, some of the bearing problems can be a little tricky. Okay, you will have a couple practice problems to work on, and we'll do more with this next week. But I would definitely make sure you get help when you need it. Okay, have a good one, guys.